Question 1 from the 2025 Higher Physics Examination from the SQA from Paper 2. A television company uses a spider cam to film a sporting event. We've all seen this in the penalty shootouts in football grounds. The spider cam is made up of a camera mount that carries a camera. Now, the camera mount is suspended from 4 cables, as you can see in this diagram here. The length of the cables can be changed using a motor attached to each cable. There's a motor here, and the motor pulls the cables, and you can have the spider cam moving. This allows the height and position of the camera over the pitch to be changed. So we see what's happening. Now, what's going to be our first question here? The first question is the camera mount and the camera have a maximum acceleration of 1.45 meters per second every second. That's how you pronounce acceleration. And a maximum velocity of 8.86 meters per second. And we have for 1 mark to state what is meant by the acceleration of 1.45 meters per second every second. And that's the definition there. 1.45 meters per second every second, that's how we pronounce that, means that the object's velocity or speed, if we're talking about magnitude, will increase at 1.45 meters per second every second. You can think of the table, which just for 1 mark, that statement would be enough. But there's a table there showing you the increase of this object if it has an acceleration of 1.45 meters per second every second. Every second, it's going to have an increase in its velocity of 1.45 meters per second. And you can see the increase going to 2 seconds and going to 3 seconds. Another way to describe that, if you want, but you don't have to put this in for just 1 mark, would be the graph of the object here. That would be time, that would be velocity, and the graph would look like that, straight line. And the gradient would be actually equal to the acceleration. The gradient would be equal to acceleration. And we know that if we work that out, the gradient would be 1.45 meters per second every second. So that's all we have to say for that one. A quick answer for that, just giving you a bit extra there. 1.45 meters per second every second means that the object's velocity will increase by 1.45 meters per second every second. Now, part 2, it says calculate the distance travelled by the camera mount and the camera as they accelerate at 1.45 meters per second every second from rest to the maximum velocity. Well, this is going to be a kinematics one, so we put down our kinematic relationships. U, V, A, S and T, U being the initial velocity, V being the final velocity, A being acceleration, S being the displacement, and T being the time. And we just fill things in. It's going from rest, so the initial velocity is going to be 0, and the maximum velocity is going to be 8.86. We can put that into that part of our list there. Velocity is going to be 8.86 meters per second. We know the acceleration because we've been told that it is going to be 1.45 and it's going to be meters per second every second. And we asked to find the displacement of S. We've not been given anything to do with the time there. So we're looking for an equation in our relationship sheet which has got U, V, A and S, and that's the equation we're going to have to use. We find out it's going to be V squared, it's going to equal to U squared, plus 2 times acceleration times the displacement. Now, you could put the numbers in and rearrange with the numbers. I tend to rearrange first, practice this, and if you do this, you get V squared minus U squared is going to equal to 2AS, and therefore V squared minus U squared, all divided by 2 times A, is going to give you the displacement S, like that. So all we have to do is put in the numbers. V squared, we know it's going to be equal to 8.86. So 8.86 squared, take away nothing squared, put that in a bracket to protect it, and divide by 2 times acceleration, 2 times 1.45, and put that in a bracket to protect it. Do it in your calculator, and you end up with an answer of 27.068. Now, we'll be looking at 3 significant figures, so therefore we can put our answer down as 27.1, and it's going to be meters for 3 significant figures. Question 1 continued part B. During a test of the system, the camera mount and camera are held stationary at a constant maximum height above the centre of the pitch. The total mass of the camera mount and camera is 31 kilograms, and at a maximum height, the angle at which each cable makes to the horizontal is 12 degrees. And for 4 marks, we've got to determine the tension T in each of the 4 cables. So if we look at just one cable, we can see the one cable here. Now that one cable is just responsible for holding up a quarter of the weight of the camera and the camera mount. Think about it. There are 4 cables there. They're going to provide 4 vertical forces, vertical components of the force, which means that the weight of the camera, which is holding up, if we look at just one cable, will be this force here. And it'll just be a quarter of the weight. But remember, we're looking at just at one of the cables. We've got another 4 of these cables, and of course they'll support the mass mg, but one of them will support the mass of mg divided by 4, a quarter of the weight. And likewise, if we complete the triangular forces, the upward force here must be mg over 4 as well. So we've got a complete triangle here. We've got this part here, which is the right angle in there. We've got the angle here. We've got the tension defined. So we've got all the triangle there. We can use our trig now. We can use sine 12 equals opposite over hypotenuse. Remember, that's the opposite side. And that's going to be the hypotenuse side. That's going to be the adjacent side. So what we can do now is just complete our trig. We can say that sine of 12 degrees is going to go to the opposite side, which is going to be mg over 4, a quarter of the weight, and we're going to divide that by the hypotenuse, which is going to be tension T. A wee bit of rearranging to do here, and therefore we have T multiplied by sine 12 degrees should equal a quarter of the weight, and we'll put that down as 1/4 mg. And therefore, to find the tension in one of the cables, the tension T is going to do 1/4 of the weight of the camera and the camera mount divided by sine of 12 degrees. So if we plug that into a calculator, we know that the mass of the camera mount, 1/4, is going to be mass, going to be 31, and multiplied by 9.8, which is the gravitational field strength, all divided by sine 12 degrees. And we do that on my calculator, we end up with the tension of 365.30 newtons. And we can put that into 2 significant figures and call it 370 newtons to 2 significant figures. So each cable is responsible for a tension in each cable is going to be 370 newtons. And remember, you're going to have 4 of those cables. Now the hard part of that problem is to find out what the actual weight which you're supporting is. Remember, we're looking at just one of the cables. There are 4 such cables. So therefore, if we look at just one cable on its own, the tension of the cable will be upholding or supporting just a quarter of the weight, the other 3 cables taking up the rest of the weight. So once we get the diagram done like that, it's quite straightforward to look at the trig of this and come up with the final answer that the tension in one of the cables is 370 newtons.